So last class you learned the definition of a derivative. The definition of the derivative is the limit as the horizontal distance between your x's goes to 0. You are finding the slope as that distance gets shorter and shorter and shorter to find the instantaneous rate of change at one point. And that is what a derivative finds. The derivative finds the slope of the tangent line at any given point. Okay, now, now that you've learned the hard way, I'm going to show you rules. And these rules, once you get the hang of them, are going to make finding derivatives super short and quick. So why did I torture you? With the long way is, well, number one, you need to understand what a derivative is and what it came from. But number two, also, they are going to ask you multiple choice questions that involve the definition of the derivative. So it is a very important concept that we not only learn, but make sure that we keep fresh. Okay, so here are two rules that we're going to learn. If f of x is a, which is a constant, then f prime of x is 0. Let's make sure this makes sense. If I have y equals a constant, that's like y equals 5. That's a horizontal line, and the slope of every point on that line is 0. Slope of the tangent line to any point on a horizontal line is 0. So the derivative of a constant is always 0. And I think I said yesterday, or in the last notes, that the derivative is always one power beneath the original function. So if your little original function is degree 0, because it has no x's, then your derivative is going to be a 0. And the next one, which is going to be the one that you're going to use the absolute most, and he's going to be involved in all of the other derivative rules, so this one's really important. If you have a function that is x to the k, where k is some power, then f prime of x is, bring the power down front, and then subtract 1 from the power. Okay, so let's look at the first 4 examples. You cannot just write what it is. You have to denote what you're finding. So I'm going to write f prime of x equals, and 7 is a constant, so I know my derivative is going to be a 0. F prime of x equals, negative 3 is a constant, so I know my derivative is going to be a 0. For number 3, we're using the power rule, so f prime of x equals, bring the power down front, and subtract 1 from your power. Number 4, the derivative, bring your power down front and subtract 1 from your power. Number 5, this is a power rule. Bring your power down front. There's already a 4 there, so we're going to multiply and get a 12. And take 1 off of your power. Now, please make sure you understand that that 4 is not a constant, so don't tell me that the derivative of that is a 0. That's not true. If it was just a 4, yes, but that's not. That's a 4x cubed. So I'm bringing the power down front, multiplying by what's out there, and then taking 1 from my power. Okay, we're going to dabble in some fractions. I know it's going to be negative. Bring the power down front. That's a 2, which is 2 over 1. So that would be 8/5 x to the 1. Okay, number 7, we're going to leave it as 6x to the negative third. I'm not going to move that to a bottom. I'm just going to do my power rules. So f prime of x equals negative 18 x to the, now be careful, you are subtracting 1 from your power. So that's a negative 4. Now multiple choice could write it like that if they wanted to. I'm fine with either way. You just make sure that you are capable of going both ways, and then as we start to use them, you'll start to see when it's appropriate to do one or the other. Okay, number 8. I want you to see number 8 as a negative 3 over 2 times an x, just like number 5 and number 6 and number 7. I have a coefficient and I have an x. I don't want you to look at that as a negative 3x and then it's over 2. Okay, so f prime of x is, okay, now this one's cool. Bring the power down front. That's a 1. So my 3 over 2 is going to stay put, and then I'm going to subtract 1 from my x. That's going to be x to the 0, and x to the 0 is 1. So I'm not going to write it. Again, remember, your derivative is 1 degree less than your original function. So if he is a degree 1, he should be a degree 0, meaning he shouldn't have an x. Okay, number 9, f prime. Bring your power down front and subtract 1 from your exponent. So number 10, if I'm going to take the derivative, bring your power down front and take 1 off of your x. Okay, let's pause for a second here. I hope you've seen a trend in number 8 and number 9 and number 10. If you have a number times a plain x, the derivative is just the coefficient. The x just goes away. So just kind of start looking for that. Okay, number 11, f prime of x. I'm going to bring my power down front and subtract 1 from my power. Okay, so that's kind of all the easy ones. So now I'm going to give you a nice little nugget of information. And if you will follow this nugget of information, I promise it will make your life easier going forward. And we have a long road ahead of us. This is our first step. Derivatives are won and lost in the prep. So I want you to think about like going in for surgery. There's this prep that happens before you go in for surgery. There are utensils that have to be out. You have to be put under. Everything has to be sterilized. Like there's just a procedure before you ever start the main show, the surgery. So for number 12, and honestly, everything that you see on this screen from here out, the prep work before you do the calculus, the algebra prep work is the most important thing. So for number 12, I'm not ready to do the derivative. I want to write this as a power. Now notice, I did not write f prime. I'm not doing calculus right now. I'm doing algebra. This is x to the 1/3. Remember, power over root. Okay? So now I can use my power rule, bring my power down front, and subtract 1 from my power. Now if I subtract 1, that's the same thing as minus a 3 over 3. So 1/3 minus 3/3 would give me a negative 2/3. Now sometimes that's the answer, but sometimes they clean it up because they want to just test your algebra skills. So remember that negative means move that x to the bottom. The 2 on the top means square it, and the 3 on the bottom means cube root it. All the while, I have a 1/3 in the front. So technically, this is what I have. Now pause it and make sure that you're good with where everything came from. 1/3 x to the negative power over root. I'm totally fine with this, but you need to be okay if they go here, or if the problem warrants you doing that because it makes something down the road easier. Okay, so number 13, I'm going to do the prep work. Notice I'm not putting f prime because that would be very poor notation. All I'm doing right now is algebra. This is going to be 2x to the 1/2. Now I'm going to do the calculus. Pull the power down front. 2 times 1/2 would be 1. Take 1 from my power, so minus a 2 over 2, and 1/2 minus 2 over 2 is a negative 1/2. Technically that's done, but if you wanted to clean it up, it would be 1 over the square root of x. And I think I did a video on powers for this very reason before school started. So if you're iffy on this moving the negative exponents and power over root, feel free to go back and watch that video. Okay, number 14. All right, now some people will do this. They'll say, okay, I got you, Miss Patterson. I'm going to do this 2x to the 2/3, and then I'm going to do my power rule down here in the basement, in the denominator. You can't do that. you can't do the power rule isolated in the denominator. It has to be the power rule on the function as a whole. So again, another algebra step, another prep step. I'm going to write this as 1/2 x to the negative 2/3 to pull it out of the denominator back up to the top. Now I'm going to do the calculus. So f prime of x equals, all right, I'm going to bring the power down front, so 1/2 times the negative 2/3. The 2's are going to cancel. It's going to give me a negative 1/3 x to the, and then if I subtract 1, that's going to give me a negative 5/3. Now, you can write it like that, or let me the cube root of x to the 5th, all on the bottom. And again, I'm moving at a pretty quick pace because I know that you can pause this video and finish writing or let things digest or go back and walk back through it as you need to. Number 15, again, I'm going to do some algebra prep work first. Then I'm going to do my calculus. I'm going to bring the negative 2 down front, and then I'm going to subtract 1 from my power. And I could leave it like that, or that's what it reduces to. Negative 2 stays on top, x to the negative 3rd moves to the bottoms. Just sharpening those skills, because for this road that we're about to walk down, these crunchy skills need to be really sharp. Okay, again, number 16, a little prep work. Okay, now the calculus. Bring the power down and subtract 1 from my power. Could leave it like that, or could simplify it or clean it up a little bit. All right. Okay, let's see. Prep work. 5/2. I'm just going to kind of pull that out to the side. Now I have an x to the 3rd on the bottom, so that would be x to the negative 3rd. So there's my prep work. Going to pull the negative 3 down front. That's going to give me a negative 15 over 2, x to the negative 4th. So that gives me negative 15 over 2x to the 4th. Number 18, 100% going to clean this up first. I'm not going to do this. I'm not going to write this because you don't know how to do that yet. So I'm going to cube everything on the bottom. Then I'm going to separate and pull him up. Now I can do the power rule. Pull that down. That would be negative 15 over 8, x to the negative 4th. Number 20. Again, pull the 7/3 out. That is x to the negative 2, so that would be x to the positive 2. If I move him up, then the calculus part, bring the 2 down, that would be 14/3 x to the 1. 21, I'm going to treat like 18. And notice 17 and 18 are very similar. 20 and 21 are very similar. I'm trying to show you the difference in the parentheses versus the not parentheses. Clean the parentheses up first. So 7 over, okay, now 3 to the negative 2 is not 9. It's a 9 that moves up to the top. And that x to the negative 2 is going to get moved up to the top also. So technically, I have 63x squared. Then I do the calculus, 126x. All right, now I'm looking at big long polynomials. So guys, what you're going to do is everything through 21 has been isolated monomials. So when you look at 22, every term just gets that power rule. Okay, so every single term gets that power rule. So I'm going to look at x cubed. I'm going to pull the 3 down front, knock 1 off my power, minus 4, because I'm bringing the 1 down and then knocking 1 off my power. And remember, the derivative of a negative 4x, it's just a negative 4. And then remember, derivative of a constant is 0. And if you want to pause this and try this problem and then hit play and see if you get it right, that would be great. So let's see, negative 8x cubed plus, bring the power down, that'd be 3/2 x squared minus 2x to the first plus 6, and the 8 goes to a 0. Okay, 24, going to do just a little bit of prep work just to make it look normal or kind of fit in this nice little box that we as mathematicians really like. Now I'm going to do the derivative. Again, pause it, then check it. Okay? So bring the 4 down, that'd be negative 2x to the third plus 9x squared minus 2. Little prep work. 1/3 x to the power over root. Okay, so now derivative. All right. Bring the power down, so 5/2 times 1/3 would be 5/6. Again, top times top, bottom times bottom. And then if I subtract 1, which would be 2/2, that would give me 3/2 minus 12x squared. And the 8 goes to 0. Again, I hope you're seeing the importance of the prep work before you can do the power rule. The power rule is unforgiving. It has to look like this being a number and this being a number. And this can be a fraction, that's fine. This right now cannot. Okay. Okay, prep work. Again, pause it and do this one and then see if you get it right. 6x to the negative 1/2 plus 5x squared plus 4x. So f prime of x equals and you guys can see how fast I'm doing these. You will get that fast, I promise. By the end of this homework, you will be that fast. Okay, 27. 27 does not fit into that box. You cannot apply the power rule when you have a numerator and a denominator with x's in both. But you can separate this. So guys, this is one of the biggest ones that people forget to prep him first. If you are dividing by a single term, pull it apart. Pull it apart. If you are dividing by a single term, pull it apart. So that would give me 3x minus 1 plus 1 over x. Here's what I did. I just did it in my head. And then I cleaned them all up. Okay, I still can't pull the trigger yet. There we go. Now I can. 3. Constant goes to 0. And for this guy, pull the power down and subtract 1 from your power, which, if they wanted to, could do this. Oh, but they could also do this. And that's getting a common denominator. So I hope you guys can see all of those foundational skills that we laid in pre-cal, the common denominator, the GCFing, the powers, the fractions, the multiplying and the dividing and the adding and subtracting of fractions, all that stuff now, we use it like it was just, it's just right there on the tip of your fingers. Okay, last two and then we go trig. And you're going to find in calculus that when I approach a new concept, it's always, okay, let's do this with algebra, and oh yes, now we're going to do it with trig. Okay, so 28, you cannot use the power rule. Later, you'll be able to use a different rule on this, but for right now, you can't. So I can't use the power rule, so I need to clean. So f of x equals 4x squared minus 6 minus 6. So minus 12x plus 9. Now I can do it. There you go. Pull the power down, subtract 1. The derivative of anything with an x is just the coefficient. The derivative of a constant is 0. 29. Cannot do the calculus yet. Now I can. Here we go. Okay, trig. Before we dive into the trig, these little buddies rear their ugly faces several times. So, number 1, the Pythagoreans. Sine squared cosine squared equals 1. We know that one. 1 plus tangent squared equals secant squared. 1 plus cotangent squared equals cosecant squared. I hope those are still in the noggin. The double angle formulas in pre-cal, I did not make you memorize this, any of these. And honestly, guys, the one that pops the most is him. And you need to start the memorization process for him. Sine of 2 theta or 2u or 2x, whatever, is 2 sine of u cosine of u. Again, this is a double angle formula. It takes a double angle and reduces it to a single angle. So it's sine of 2x equals 2 sine of x cosine of x. These two, or 3 for cosine, let's just put those on hold for a second and see if they pop up. Tangent never pops up, so don't worry about him. Okay, so you got the trig stamp. Trig stamp, which you know sine, cosine, tangent, cosecant, secant, cotangent. You know who's buddies, S and C, C and S. So it's highlighted in yellow is your good old best friend, the trig stamp. Okay, now the d over dx in the front says I'm getting ready to take the derivative of sine of x. I'm going to take the derivative of cosine of x. I'm taking the derivative of tangent of x. Okay, so you have to memorize these because you're going to use them a lot. So the derivative of sine is cosine. The derivative of cosine is negative sine. The derivative of tangent, secant squared. Now remember, tangent and secant are Pythagorean buddies. So they are also derivative buddies. Remember, 1 plus tangent squared equals secant squared. So they are Pythagorean buddies. So they're in it for derivatives too. But it's derivative of a plane tangent gives you a secant squared. The derivative of cosecant is negative cosecant cotangent. The derivative of secant is secant tangent. Okay, let's stop right here. We just talked about how secant and tangent are Pythagorean buddies. Well, cosecant and cotangent are also Pythagorean buddies. So, cosecant and secant, honestly, this is how I remember these. Y'all know I come up with stupid ways to remember stuff. Secant and cosecant kind of feel like the redhead stepchildren of the trig stamp. They don't get a lot of love. Sine, cosine, tangent, tons of love. Cotangent, he gets love from tangent. Secant and cosecant are kind of the low men on the totem pole. So they are so frustrated with that they put themselves in their derivatives. That's how I remember it. Secant and cosecant put themselves, they don't feel like they get enough love. So they have put themselves in their derivative, and then they're multiplied by their Pythagorean buddy. So cosecant is a and I'm going to address the positive and negatives here in a second. Cosecant is negative cosecant cotangent. Secant is secant tangent. Cotangent kind of follows tangent's lead. Cotangent is a negative cosecant squared. Again, remember cotangent and cosecant are Pythagorean buddies. So tangent and cotangent are the two that end up with somebody squared. Nobody else ends up with anybody squared. Secant and cosecant put themselves in their derivative, and sine and cosine are each other's buddies. Now, let's address the negatives. Okay, now I want you to notice the green highlighted negatives only pop up for derivatives of a trig that starts with the letter C. Now, I'm not saying the answer starts with the letter C. I'm saying what I am taking the derivative of starts with a letter C. Then the derivative of that value is negative. Sine, tangent, and secant do not start with the letter C. Their derivatives are not negative. Cosine, cosecant, and cotangent all start with a C, and their derivatives are negative. Okay, so stay with me right here. Sine, cosine, tangent. Don't look at your notes. Cosecant, secant, cotangent. Sine and cosine are each other's buddies, are derivative buddies. So the derivative of sine of x, so d dx, the derivative of sine of x is cosine of x. The derivative of cosine that starts with the letter C is negative sine of x. The derivative of tangent is secant squared x. The derivative of cotangent, starts with a C, is negative cosecant squared x. Those two are both squared. Cosecant and secant don't feel like they get any love. They put themselves in their derivatives and they use their Pythagorean buddy. So the derivative of cosecant is negative cosecant cotangent. The derivative of secant is secant tangent. Flashcards. I'm sure Quizlet has some out there already made. Feel free. Make them yourself. That way they'll always be with you. Okay. Here I go. I want the derivative. So f prime of x. Now 2 sine, the 2 is just chilling. So that's going to be 2 cosine x because the derivative of sine is cosine. And the 2 is just hanging out. So guys, this is not a power rule. I'm not bringing any powers down and knocking one off the power. This is trig. We've totally changed gears. Okay, 31, I'm going to rewrite it so that it looks linear, like normal, not quotient-y. So f prime of x equals, all right, the derivative of sine is cosine. So 1/2 cosine x. All right, now 32. Guys, you got two things going on here. You got trig, which you just learned, and you got a plane x, which is your power rule. So f prime of x equals, bring your power down, then subtract 1 off your power, that would be x to the 0. So that's a 1. The derivative of cosine, ooh, that starts with a c. That's going to be minus sine x. So I have two different rules in that. Okay, these are both trig. Cosine starts with a c, so negative sine x. Sine starts with an s, so the sign does not, the sign sign does not change. And the derivative of sine is cosine. 34, that's power rule, that's trig rule. f prime of x, derivative of x is 1. Tangent starts with the t, so the SIGN sign does not change, and his derivative is secant squared. Now, you know what they could do on 34? This was multiple choice. They could not have that as an answer because they could make the answer negative tangent squared, because 1 minus secant squared would be a negative tangent squared. Oh, they'll do it too. They'll do it in a quick minute, because otherwise that's a very easy problem in their eyes. It's just a rule. So if it's just a rule, they're going to throw some sort of twist in there. So just be careful. Remember, if you see a 1 and something squared, think Pythagoreans. So, and I'm going to be real honest, if they have the potential to do it, I have the potential to do it, because I'm trying to get you ready for them. Okay. The last rule that you have to learn for the day. So you've learned 2 rules so far. You've learned your power rule, and you've learned all the trig rules. So now we're going to learn the product rule. The product rule is when you have 2 functions multiplied together. Here's what you're going to do. Now it has to be 2 functions, so 2 things with x's in them. So this guy times this guy, so f times g. Okay, here's what you're going to do. You're going to take f and leave him alone, and you're going to multiply him by the derivative of g. And then plus, then you can take the derivative of f, and then you're going to leave g. So here's what I'm going to, this is the first one, f is the first one, g is the second one. So first you're going to leave it, take the derivative, plus take the derivative, leave it. So leave it, take the derivative, plus take the derivative, leave it. Now, looking at 35, if 15 minutes ago I had given you 35, your answer should have been, we have to prep it first. We have to lobster. Okay, absolutely. So I'm going to do this sidebar. So just watch. So if I lobstered this, that would be 15x plus 12x squared minus 10x squared minus 8x cubed. So 15x plus 2x squared minus 8x cubed. And then if I take the derivative of that, there you go. Okay. But now I'm going to do it using the product rule. So here I go. H prime of x equals, okay, leave it, take the derivative. Well, he would go to 0, and he's going to a 4. Plus, I'm right here, derivative, that would be 3 minus 4x, leave it. Okay, now technically you're done. You've just taken the derivative. But if it's multiple choice, guys, odds are it's going to look like him. So I'm still going. I'm going to multiply the 4, and I'm going to lobster this out. And then I'm going to clean. There's a 15. There's an x and an x and an x. 24 minus 20, that's a 4. And a negative 8 and a negative 16 is a negative 24x squared. Looky there. Get the same thing. Now, you should be sitting there saying, well, why on earth would I do the product rule? I would rather just lobster it out and use the power rule. I agree. But you can't always do that. So on number 35, absolutely. Lobster that sucker out and roll into the power rule. 100%. However, look at number 36. Okay, guys, you have 3 things going on here. You have a 2x, you have a cosine of x, and then you have a minus 2 sine of x. This is the product rule. This is just trig. The product rule, however, has trig in it. The product rule has a power rule and trig in it. So guys, you have to be able to see that that 2x, that's a function. And cosine of x, that's a whole separate function. If it's just a 2 times sine of x, that's only one function. There's only one x. But this is two functions being multiplied together, so I have to use the product rule. So here I go. Leave it, derivative. Now the derivative of a cosine, starts with a C, is negative sine x. Notice I use parentheses because I don't want that to look like 2x minus sine. That's 2x times a negative sine. Plus, now I'm going to take the derivative of the 2x, that's a 2, and then leave the cosine of x. So guys, what you have just done, what this is right here, is the derivative of that. All you've done is the product rule. Now I got to do this little booger on the end. Minus 2 sine x, that's a sine that goes to cosine, so 2 cosine x. Okay, now look, you've got three terms. I've got this guy and this guy and this guy. I'm done with the calculus. I'm done with the derivatives. These two are going to cancel. And I'm going to get negative 2x sine x. Just watch your algebra. Okay, 37. First thing I'm going to do is I'm going to do a little prep work and make him x to the 1/2, 1 minus x squared. Okay, now you have a choice. Because on this one, you know power rules, like not calculus power rules, algebra power rules. I could do the product rule, the x to the 1/2 being your f of x and the 1 minus x squared being your g of x. Or I could distribute, fluff it out a little bit, and not do a power rule. So x to the 1/2 times 1 is x to the 1/2. X to the 1/2 times the negative x squared. Remember, when you multiply, you add your powers. So 2 plus 1/2, 2, that would be 4 halves plus a 1/2, that would be 5 halves. Now look at it. Again, I've done no calculus whatsoever. That's all prep work. That's all algebra. But now I don't have to use the product rule. I can just use the power rule on them individually because now nobody's being multiplied by anything. So bring the power down front, take 1 off the power. Bring the power down front, take 1 off the power. Then if they wanted to, they could make you clean this up and say, okay, this is 1 over 2 root x minus 5 square root of x third over 2. They could do that. They could be all fuller and make you get a common denominator, although I don't think they would. But I wouldn't put it past them. Okay, stay with me. Home stretch. All right. I see 3 functions being multiplied. I see an x squared, I see a sine of x, and I see a cosine of x. So I have f times g times h. So here's what I'm going to do. I'm going to leave it, derivative, plus, leave it, derivative, leave it, plus, derivative, leave it. So leave it, derivative, plus, leave it, derivative, leave it, plus, derivative, leave it. Okay, but now let's be honest. It's all addition. So it doesn't matter the order in which you do this. The point is you have 3 terms. And you take the derivative of 1 and leave the other 2. Plus, take the derivative of another one and leave the other 2. Plus, derivative of the third one and leave the other 2. It's all addition. It does not matter the order in which you do this. Leave it, derivative. Negative because it starts with a C. Plus, leave it, derivative, leave it. Plus, power rule, derivative, leave it, leave it. Ooh, that looks familiar. We just talked about him. H prime of x equals negative x squared sine squared x. Pause. Take the negative up to the top, left the x squared. Sine times sine is sine squared. Sine times sine is not sine of x squared. That squares the of. I'm not trying to square the of, I'm squaring the sine. This is going to give me x squared times cosine squared of x. And 2x sine x cosine x is sine of 2x. Double angle formula. All right. I could be done. I might not be done. I don't think I'm done. Oh. See, I'm seeing the sine squared and the cosine squared. But their sines, SIGNs, are not the same. So if I GCF'd negative x squared out, that would give me sine squared x minus cosine squared x, and they are not related. They have to be the same sign. So I don't think, I wanted to go Pythagorean and turn that into a 1 somehow, but it's not going to work. But I tell you what, if this sign right here was a positive, I'd be all over it. If that sign was a positive, I would GCF an x squared. And then that would go to 1, and I'd have an x squared plus sine of 2x from over there. 100%. Okay, 39. Two different functions, product rule. Here's one, here's the other. Okay, so h prime. Leave it. Derivative. Now derivative secant. Remember secant gets no love, puts himself in his derivative. He does not start with a c, so no negative. So he's secant, who's his buddy? Tangent. Okay, plus derivative, well, the derivative of x is just going to be a 1. Think about it. Bring your power down. So 1 secant. Technically, that's all you can do. If you wanted to GCF a secant out, you could have x tangent x plus 1. Like that would be totally fine, but not necessary. But might be necessary down the road when we start applying this stuff if we needed a secant to cancel with something else. So I will take either answer, but don't write off the second answer. Just kind of keep that churning. Look for ways to simplify it in the back of your noggin. Number 40, I have taught you absolutely no rules for how to take derivatives of division. So you cannot take the derivative of this. So fix it. I'm going to write it as x to the negative 1 times cosine x. That's the prep work. Now I'm going to take the derivative. So I'm going to leave it. Derivative of cosine, which starts with the c, that's going to be negative sine x plus derivative, bring the power down, take 1 from the power, leave it. That's my product rule. I'm going to clean it up. I got negative sine x over x minus cosine x over x squared. Could get a common denominator because that would be easy just to give the sine an x and put it all over an x squared, but not necessary. But again, if you were going to do that, that would just be x sine x. There you go. Okay, last two. Don't let your brain ooze out of your ears yet. Hang tight. Okay, product rule. Here's one function. There's the other function. Okay, tell you what. Pause this. Try 41 on your own. Product rule. Leave it derivative plus derivative leave it. Good notation with the h prime. Leave it. Derivative of tangent is secant squared plus derivative. Leave it. You could GCF a 4. I don't think that does much of anything. Now, if that tangent was squared, maybe I could go Pythagorean, but I don't think the signs would be right. But anyway, either answer would be fine. Okay, number 42. Listen very carefully. The power rule does not apply to trig. I repeat, the power rule does not apply to trig. You cannot bring the 2 down, write cosine, and then take 1 from your power. You cannot do it. So I need to know how to take this derivative using rules that you know. You know power and you know product. You cannot use power on a trig, so that only leaves product. So instead of thinking this as a cosine squared, think of it as cosine times cosine. Here are my 2 functions. Now pause and go product rule on this sucker. I'm just rearranging it so they look similar because now they are like terms. Okay, those are your rules. Now, I know it's a lot to write as you learn, so I would recommend, now that you've written it all down, go rewatch this video without writing anything down. Now that you've seen the rules, now your brain should be able to go at them a little bit faster. So rewatch this video and see if it just settles better, if it's unsettled.